Hello. So this fourth presentation gets back to Istio traffic management and explores some more advanced scenarios compared to what we did before. If you remember, in the first presentation I was demonstrating how you can route your request based on a specific error, and that is a very important feature because it enables you to really differentiate the deployment from the release of an application. And I think it's key because if you can deploy an application without actually impacting your user, then you can do a lot of things. Now, Istio comes with a lot more traffic management features, and you can address advanced use cases. For instance, you can not only perform blue-green updates, but also canary updates. You can create some kind of shadow traffic to test your components. You can introduce some failures, and also to test the components. And also you can use the circuit breaking feature to say eject a component that is not behaving as it should, or simply because it's overloaded, not provide the associated service, so that the user obviously will get a degraded set of features, but it won't impact everybody. So there are many features, and obviously I won't be able to explain everything, so I want to keep things short. So what I'll do, I'll be focusing on the demonstration. If you want to know more, have a look at the istio.io website and refer to the documentation. In particular, you'll want to have a look at the tasks traffic management section of it, and you'll learn a lot. Now let's start with the demonstration. I really encourage you to try those demonstrations for yourself. So there are only a few things you might want to know before actually doing that. First, obviously, we'll have to have a properly installed and configured Istio configuration, in that case on top of Kubernetes. And also, one important thing for this demonstration is that assume that the mutual TLS is not activated on your cluster. So if it's the case, then you would have to change the destination rule declaration and add the TLS section as part of them. Other than that, you can access the directory that is called blog/istio-advanced-routing as part of my Cloud for Fun project, and you'll get all the manifest in there. So pretty easy, you can just clone the directory or fork it and play with it. So before we start, we actually need to get access to Istio. The configuration I'm running right now is based on an EKS cluster on AWS. So I need to actually get access to the gateway endpoint. And in order to do that, I will just query the service. So we'll keep control get service for the gateway, and here it is. I'll get the CNAME for the gateway. In the script, I've been using a simple GW environment variable, right? And also I've created a set of manifests that you can download and use. The first one is actually the application itself. So it's made of a service and 3 deployments. The deployments have labels for the pods. Here we do have a label for the app that is recursed, so the application will be recursed, but there is also a version we'll use as a subset of our application. So we'll have version 1 in that case. It relies on the recursed container you can download on Docker Hub, and you'll see there is a version 2 here. So what is different is obviously the version, but also the delay. So version 2 that actually takes 2 seconds to answer to my queries, and it displays version 2. And also there is version 3, which is basically the same as version 1 except for the version. So I can just create those will be started, and because Istio is installed, you can see that if I run control get pods, here there are sidecars associated with the files. Okay, I can go on. So there is also a gateway, an Istio gateway. So it's a very basic gateway, get the values for everything. I can just apply it. And last but not least, there is the virtual service. So for now, it's a very basic virtual service. It will access the recurse gateway, and it will send the load to any pod that has recurse in the app. So I can just apply that one too. Here it is. I should be able to access the gateway for my hello root. Here it is, and you see that it's answering with the host name of the pod. Also the delay. So in that case, there is no delay. And the version, if I run a few queries, you'll see that it's actually doing some round robin across the different pods. And if I get to version 2, I get a small delay of 2 seconds. Before I can go on, I've created a script. So we'll just copy the GW environment variable, and I will run the test.sh script. So what it does, basically just query the endpoints, and depending on the output of the version, it will have a different color coding. And what I'll do too is just here, I will get the pods. And here I will query the logs for the recurse container. In my pod. Right, so I'm querying the logs for version 3. If you have a look, every time it hits version 3, it should display a log. Here it is, right? Okay, so we are ready to go on. And first thing, I'll be showing you the destination rule. So the destination rule allows you to define some subsets. Here I've named 3 different subsets, v1, v2, v3, and each subset matches a label that is version. So version 3 will access the pods that have v1 for version as a label, version 2 v2, and version 3 v3. So basically I can just apply that destination rule manifest. It won't change anything, obviously, right? That's because I'm not relying on it. But if you look at the next manifest, you'll see that in the destination I can point to a specific subset, so say version 1, and if I apply that, you should see, right, that yeah, it's moving all the load to version 1 now. Right, so that's something very useful to decide which one of our pods we want to point, and to do stuff like canary updates or blue-green updates. Very simple. So say we want to move to version 2. There is basically the same manifest, except that it's pointing to version 2. Right, the subset pointed by that manifest is for version 2, so I can just apply it. Here it is. I should see that, yeah, it has moved to version 2. So because there is a small delay, it's taking some time, but that's not because of the update, but because of delay in the root itself. Right. There you can see there is no hit to version 3, obviously. Oops. Okay, so now if I want to move to the load between two different containers or two different pods that have containers, I'll show you how you can do that. You can have a look at the 7th manifest. Here you see, instead of having only one destination, I have two with a weight. So let's say I'm currently running on version 2. Let's say I want to update this. And have version 1 that are set for 80% of the containers, and version 3 because I don't want to have the delay for 20%. I will now just apply the manifest. And you see that there is now version 2 and version 1 and version 3 that are being accessed, and the spread should be around 80% compared to 20%. Every time it gets to version 3, it continues to lock the thing, right? Okay, so if I want to provide more load to version 3, I will just update the manifest, move, say, so that it can be significant. I will do the opposite. Right, just apply it again, and you should see the trend being changed. So you can see that now it's serving more of version 3 compared to version 2, to version 1, sorry. Okay, so now let's say that I will go back to version 1 only. Okay, well, take a while, and now I will show you another feature of the virtual service, and that's called the mirroring. So that's the 8th manifest. And it shows that now it's in this manifest, it will send all the load to the subset V1, except that there is another keyword in that case, and it says that it will also mirror the load to the subset V3 of the recursed application. So as you can see, it's currently the user are accessing version 1, but there is currently nothing hitting version 3. So I will just apply that manifest. And nothing should change for the user, but now you see that version 3 is being used. And it's very useful if you want to create what we call a shadow set of requests behind the scene to test the application while using the former application to the user. So it can be used to perform some tests. Obviously, you don't want to do that if there is some change in the data, for instance. So you will really focus on what you want, or you will mock your queries. But that's very useful to see how a new service will behave. So let's continue with another feature, and that's called the fault. So let's say I'll stick back to version 1. There it is. You see that version 3 shouldn't. Yeah, it is. So I'll show you the manifest. So manifest is this one, and now there is a new keyword, and this keyword is fault keyword, so you can introduce a fault as part of the query. So useful again to test what's happening. And in that case, what I'll do, I'll create an artificial delay in the query for 100% of the queries for version 1, right? So here, if you pay attention to that, there is the time of the query. It's rounded to seconds, so that's why there is a small one sometimes. But now I will just apply this one. And you see the query are slowing down. Right, because of the delay I've introduced. So another useful feature if you want to test your application. We'll go on, and this time we'll get back to the regular version. Right. Yeah, we're back online. So now I will show you a different way of looking at the application. What we'll do, because we have a version 2 that has a small delay, and we don't want to have response times that are bad, we will just put a timeout of 2 seconds on the on this one, and what you'll see is that if we apply that manifest, right, it will now send queries to the different versions. But in the case of version 2, because there is the small delay, we will fail. I can change it. So say we want to change those delays, right? So if we say we want to leave it 3 seconds, 3 seconds too, right? Doesn't matter, right? Because I'll get the answer in 2. And I'll apply the manifest again. Oops. Here you see now version 2 is responding to the requests. So I want to get my error back. So obviously it's a simple case, but I could say that depending on the number of requests ongoing or the connect time, I'll have an error. Here I continue to have the error. So what I like to do is have a circuit breaker to say that if there is an error on a specific pod, then I would like the pod to be ejected. So that's the part of the latest part of the demonstration. So in that case, I'll rely on the destination rule with the traffic policy. And what I'll say here is that if there is an error in a 5-sec interval, then I'd like to have my pod ejected from the current workload, and for a time base of 3 minutes. And I'm okay to get 100% of the pods ejected. So we'll just apply that. Here it is. I got my error. Yeah, what you should see right now. So what you're seeing right now is that now the version 2 of the pod is not served anymore. right? And that's because it has been injected from the set of pods that are currently being used. So it's way more advanced than what you can get from the previous example. What you just wanted to have a timeout. So in that case, I have a timeout plus I will test, and if it's not answering, I will just eject the pod. So the next presentation will be my last one about Istio, or at least for now. It will be about telemetry and how you can create some advanced monitoring configuration to better understand your application and the way the infrastructure is currently working. I really hope you liked this demonstration. If that's the case, do not hesitate to share it or simply to subscribe to the channel. Thank you for your time and see you soon.